So now in this video, I thought we'd take a quick look at the N-channel enhancement mode MOSFET. The 2N7000 is a really common one right there. I wrote the name. And what that means, there's a channel. On the other side of the channel, there's a little insulating area. On the other side of the channel is the gate. So if you make the gate positive enough, the channel gets negative enough. It fills up with electrons. So it's N-channel enhancement, which means more electrons means it conducts better. So it turns on really well. And then if you make the gate more negative, the channel gets more positive. That cuts off current. So we will look at the component. And by the way, there is no universal symbol for MOSFET. There's enhancement, depletion MOSFETs, and N-channel, P-channel. But different people use different symbols. This is the one that I like. I don't think I drew it perfectly, but it's pretty close to what the Art of Electronics made right there. I have the arrow pointing out. And some people tell me this is a P-channel enhancement MOSFET, but I've looked at the book a number of times, and this looks more like what they showed for the N-channel. But they also showed some where the arrow's pointing the other way for N-channel as well. They showed a whole bunch of them, but we're not going to dwell on that too much. Just realize there's no universal symbol. Hopefully there's a part number there, and if there is, that's going to make life a lot easier for you. So we got source to the negative supply, so flat side, that is to the left right there, which is the bottom pin. And I have it as we showed there. Gate in the middle, drain on the top, and then LED, remember long lead anode has to be more positive, short lead cathode has to be more negative, or it's not going to turn on no matter what you do. Middle pin is the gate. We got a jumper to the positive supply. So I put a little note here that you might see a pull up or pull down resistor, which is actually a really good idea. I'm going to show you why. When I pluck this, who knows what's going to happen there. It stayed on. That's because the gate builds up a charge. But there you can see it's changing, and it will change depending on how I touch it. And right now it's probably turning on and off rapidly 60 times a second right there. And it could be on, off, fully, or just some like middle ground region. So what a pull up resistor would do would mean that the LED would be on. If I yank this out, it would still be on completely with the pull up until I go to the negative supply. That's the only way I would be able to turn it off if there was a pull up resistor. If there's a pull down resistor going to the negative supply, then right now it would be on because I'm to the positive supply, but when I'm floating, that would automatically turn it off if it's a pull down resistor, because it's, you know, making a connection to ground through a resistance. And the reason why it has to be through a resistance is so I can make a direct connection to the positive supply. That'll make the gate positive, and a little current will trickle down to ground if we had a pull down resistor. So hopefully that makes sense. But yeah, it's pretty straightforward. These MOSFETs have a little bit of resistance while they are on. They don't conduct probably as good as a bipolar junction transistor. I don't know why that just dropped to 10. That's weird. Okay, we got 12. And I probably kind of lost the connection a little bit somewhere. So, in any case, we got about 12 milliamps of current flowing. I think we'd have a little bit more with the bipolar junction transistor. But this gate doesn't depend on current flowing through it. A little current shifts as it either gets more positive or more negative. And when it gets a little more positive, if you think of conventional current, that's more positive going that way to more negative. But actually electrons are filling up the N channel. So electrons are, you know, kind of making their way to the positive supply, getting filled into the channel, making it conduct better. But that's very brief. After that point, electrons are just flowing through there because the N channel filled up with enough electrons to keep a flow going. You don't have to keep, there's no way to keep a current flowing through the gate in either way, unless you damage the insulation, which would ruin the component. It just builds up a charge on one side or the other. So this is very energy efficient. We just have to give it the proper supply voltage to the gate. At that point, that's not using any current. Now all the current is going through the LED, or load, right there. So we're not wasting any, I forget what the name is, but there's a name for, you know, how much current something has to use just to maintain itself. That's not current going through the load. Is it quiescent current? I can't remember. But this doesn't depend on current flowing constantly through it for any other current other than what's going through the load. Load is getting all the current. Transistor isn't conducting perfectly, but it's conducting really good. For the most part, it's the resistor setting the current for the load, in this case, at 5 volts when it's powering an LED. Hopefully that makes sense. So in any case, that's really about it for using the N-channel MOSFET, enhancement MOSFET, as a switch. So hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.